Okay. I think I'm even going to split this up even more and do 3 examples today and then the last 2. So we did a couple of examples yesterday how to problem solve using quadratic functions. Because any kind of problem that involves reaching a maximum or reaching a minimum can be modeled and solved using quadratic functions, especially if we're asked to find the maximum or minimum, because the maximum or minimum of any quadratic function is always the vertex, right? So we use that special formula to find the vertex, and that helps us solve the problem. The first 2 problems we did yesterday, you were given the equation of the quadratic function. These ones, we have to construct them. Then we do very much the same as the way we solved those problems yesterday. Okay? There's really, and I wrote this down over here, there's really just 3 types where you're asked to find a maximum minimum product, where you're asked to find a maximum area or dimensions for a maximum area, or you're asked to find a maximum price in a business problem. Those are really the 3 types that you see. So I'd like to talk at least about 2 of them. And then I'm thinking I would strongly suggest that you practice with a couple on your own after that, before the end of this class. And then we can finish the other 2 examples on Monday. Then we've got the rest of Monday. And then we've also got all of Wednesday that will help us prepare for the next test. Okay? Okay. So here's the steps. First, we have to come up with expressions for our unknowns. This problem says find 2 numbers whose difference is 6 and whose product, what does product mean? Right, whose product is the answer when we multiply. So we need to find 2 numbers whose difference is 6, but when we multiply them, we get the lowest possible answer. Okay? Before we do it algebraically, give me an answer. Give me 2 numbers, their difference is 6. Any 2. Oh, come on. What's that? No, just give me 2 numbers whose difference is 6. Subtraction. Sorry? 12 and 6. What do we get when we multiply those? Double 36. 72. Okay, so could I pick another 2 numbers whose difference is 6 that's when I multiply they're smaller? 0 and 6. When I multiply those 2, I get 0. That's much lower. Okay. Is there another pair that works? 1 and 7, but 1 times 7 is 7, which is bigger than this. This is the smallest product you found me so far. Negative 12 and you're right, negative 6. Exactly. Do you see how the guess and check not really working too well, right? What you want to do is you want to pick 1 positive and 1 negative number that are different by 6. And then you can, because if you multiply and get a negative answer, you can get below this, okay? But clearly, just sort of doing a guess and check would take you an awfully long time. So let's use algebra. There's 2 unknowns. Let's call the first number x. What must an expression be for the second number if it has to be a difference of 6 from this? 6 plus x, or x plus 6, or even x minus 6, right? Like if you've got one number, the next number that has a difference of 6, you can either add 6 or subtract 6. So we'll add 6. That's the first step. So these are algebraic expressions for my missing numbers. What's the second step? I got to make the quadratic function. Well, I'm trying to find the max product. How do I find the max product? I've got to multiply these two numbers. So I've got to multiply x by x plus 6. And if we multiply through to get rid of the parentheses, what does it look like? X squared plus 6x, that's our quadratic function. Okay, that's our quadratic function. And what's the value of A? What's the value of B? 6. What's the value of C? There is no C, so its value is 0. And besides, we don't use C in our calculations, do we? Okay. The important ones are these two. So now what we want to do is we want to find the vertex. So we want to find the x value at the vertex. And how do we do that? Negative b over 2a, which works out to negative 6 over 2 times 1, which is, and didn't we just find x at the minimum? Which means we just found this. One of the numbers has to be negative 3. What's the other number? It's negative 3 plus 6. So we're ready to answer the question. The two numbers are negative 3 and what's the second one? Positive 3, because I just do negative 3 plus 6. Notice those two numbers have a difference of 6, and that when we multiply them together, we get negative 9. There's no other pair of numbers that we can pick that differ by 6 that gives me a lower product. That's the lowest. So now steps 1 and 2 are new in these type of problems. The second major type of problem deals with maximum area, and you're finding dimensions. So let's look at this example. You are building a rectangular fence along a lake, and you've got 800 meters of fencing to use. So let's sort of draw that problem. We've got a lake, which we're not going to put fencing on. It's rectangular, so the two widths, these two widths are going to be the same. And then this, we've got this length. All three of these pieces add up to 800 meters. So I need to find what dimensions will give me the maximum area. Because what I could do, you don't have to write this down, is I could make the widths really small and the length really long. So like, let's say I've got 800 meters of fencing. Let's say I used 50 there. Oh yeah, there we go. So let's say I used 50 there, which means I'm going to use 50 here, which means this is how much? Sorry? 100? What's my total amount of fencing? So if I've used 50 and 50, 700. So I could build one like that if I wanted to. And then I just find the area. Or I could build one where the widths are a little longer, which would make the length a little shorter. Let's say I used 100 for the widths. What would be the length if I chose 100 for the widths? 600. Does that give me a bigger area? Well, if you look at the area, remember, area is length times width. So this would give me an area of 35,000 meters squared. This would give me an area of 600,000 meters squared. So this one is obviously better. It allows me to make a bigger area. But is there another set of dimensions that is even higher than this? Okay. Again, we don't want to guess and check it. Okay. We want to try and get to the correct answer right away using algebra. So in these type of problems, we're trying to find the width and the length that give us the maximum area. Always in this type of problem, always call the width x. Trust me, it will make finding or constructing your quadratic function much easier. So we've decided to call this x. We're not sure how wide it is, which is going to give us the maximum area. What's this side then must be called? X as well, okay? Because we have two widths. But we've used a total of 800. We've used an x and an x. What would be an expression for the length? How much is left after you use two widths? Sorry? From what? From 800. 800 minus 2x. Excellent. Now we're ready to make the quadratic function by multiplying. How do you find the maximum area? Well, you multiply width by length, or length by width. And when we multiply through, what do we get? That's a quadratic function, but notice anything? How are we used to seeing a quadratic function? Yeah, the other way around, with the x squared first. So let's just rearrange it. Now you're ready to find x at the maximum, or the vertex. Remember, it's negative b over 2a. So what's b in our quadratic function? Yeah, so it becomes negative 800. And then over negative 2 times a, which is negative 2, which gives me negative 800 over 4, which is 200. What does that represent? It represents what we started right at the beginning of the question. That's the width. A width of 200 will give us the maximum area. So a width of 200 meters there, and what would be the length then? If the width is 200, what must be the length? Don't we plug 200 in here and calculate? Because isn't the length 800 minus 2 times the width? What do you get? What's 2 times 200? What's 800 minus 400? So those two dimensions give the maximum area. Sure, I answered the question. Yeah, because you were asked to determine the dimensions that will yield, which means give, the maximum area. So that's the second type of maximum problem, is dealing with areas. And when you're dealing with areas, you're going to be finding dimensions. You're going to be finding width, then length. So we're going to try one more of these. This one. Make sure you read the question carefully, because you're asked for 3 things in this problem. You're asked for the dimensions, which is width and length, and you're asked what the actual maximum area is. So this is what her enclosure looks like for her animals. She's got 280 meters of fencing to use. How can she structure that so it'll give the maximum area for her animals to roam? What's the first thing we do? What are we trying to find? What are we trying to find? What are we trying to find? I'll wait. Should I pause the video? Are we going to be a while here? You guys are going to be stubborn and I'm going to be stubborn. And I will sit here until 5 o'clock until you give me an answer. What are we trying to find, you guys? What did we find? What were we trying to find in the last question? Look at the last question. What were the unknowns? What were the unknowns? You guys, I'm asking you to read. You're making this way too complicated. What were the unknowns that we gave? Not coordinates. Can you read this word? We are trying to find the width and length. And I said, make X the width. That's what dimensions are, width and length. In our diagram, how many widths are there? How many widths do you see? 2? There's 4. 1, 2, 3, 4. So there's 4 widths. Now I need to come up with an expression for the length. How much fencing do I have? 280. And I've taken away 4 widths, haven't I? So 280 minus 4x. That leaves me this and this, 2 lengths, doesn't it? These 2 represent 280 minus 4x. But I only want one of them. Are these not the same? No. If both of these add up to 280 minus 4x, how do I find just one of them? Divide by 2. Like if I said 2 lengths add up to 100, how would you find each length? Divide by 2, 50 and 50. So what is this? What's 280 divided by 2? 140 minus 4x divided by 2. 4x divided by 2. Thank you. And now what do? We find the max area by multiplying the expressions we got for the width and the length. So the max area is the width times the length. Multiply these through to get rid of the parentheses, so I get 140x minus 2x squared. Reverse the order so the x squared term goes first before you use your negative b over 2a. Now we're going to find x, which remember what we've called x. X represents the width. How do we find it? Using the quadratic function, we got to go negative b over 2a. So we get negative 140 over 2 times negative 2. That gives me negative 140 divided by negative 4, which gives me what? 35. What does that 35 represent? The width. Good. And if I know the width is 35, how can I calculate the length? Just plug 35 into here and calculate this. So we're ready to answer the question. A width of 35 meters and length of, well, you have to do some calculating here, 140 minus 2 times 35, and that equals 70 meters, will give the maximum area. But we're not done. We're actually asked to find what is the maximum area. So how would you finish the question? What would you do to finish the question? You know the dimensions that give you the maximum area. How would you find the maximum area? Yeah, just so the max area is 35 times 70 or 70 times 35, which gives me what? 2,450? Can somebody check that? Did I get it right? Yes, no? Yes? I should be more confident in my math, like I always tell you guys to be. Okay, so I think what we'll do is we'll stop there for now.